All right. I am alive. I am here. I am ready. I am ready for Chill Spaceman game. It's time to be a chill spaceman. Live my best chill spaceman life. So let's see. Last we left off, last session was like a pretty insanely successful few hours. Last session we got the lights up on the mall with our storage of all the things. These are now showing us not only the count of what's in each machine, but also just has color-coded lights. If they're pretty full, they blend in with the wall. If it's a little empty, they start turning yellow. If it's super empty, it starts turning red. But this is a great way to just visualize what we're seeing in the mall. And that took like 30 minutes, so it was crazy fast. I think the bigger thing we did last time, which was good, is we plugged in the memory for the furnace, teaching it how to make recipes. We plugged that into the mall manager dude who's managing the mall and looking what needs to be made, and then sending items to the furnace. We got that working, or that working. And then we wrote the furnace code for the auto furnace. Got that working as well. It's just a little modification on the auto furnace that's on the ceiling. Basically do a little more custom logic for the completion phase when it's trying to hit the target pressure and temperature. And we saw that working. It was working, it was doing stuff. It was making this thing, and it made some of this thing, and then it blew fuses. And our electrical got all messed up. So that's where we left off. That's a great place to be. Right now, we need to fix the electric. And then I was thinking there's a little bit of cleanup on the code I want to do, probably. I was thinking about things we could do differently. And I think we can make some cleanup. So I might want to take a stab at that. And then we want to add more logic to the memory here. All we have to do now to teach it to cook all the advanced recipes is just provide it with a few parameters for things like what ingredients it needs, what pressure targets it's looking at, what temperature target. So we can just plug those in and see if it's working. Try and teach it all the advanced recipes, and then we can use the mall lights to see what are we low on and go farm that and fill it up. And just like see, all right, how's this working? Is this working? Is it gonna make all the recipes? Is it gonna fail on some? Can we fill up the mall? That's where we're at. This is a good place to be. So I think I want to do all that, and it is storming. I'm gonna start with a nice storm. You are good. Is Icy easy to learn from Python? Sure. It's just programming. It's just lower level programming. I'm doing some pretty tricky stuff with it, but even just basic stuff like turn on a heater if the temperature is low. It's just like immediately useful. Do recommend. Alright, I'm chilling. So what are we doing? What's going on here? What do we want to do? We need to fix the power is one thing. We got too much power on this circuit. This one circuit is like our whole mall circuit. It plugs into the machines. It plugs into all of the vending machines there. Plugs into the chutes. Everything in this whole circuit, basically. Our whole brain is on this one line. So it's got too much stuff. We need to pull some off. I think we could start with things like this. We could easily pull power off the furnace. How much does an advanced furnace take? 100 watts? That's not so bad. Anyway, we can get 100 watts here, and we can get the turbo ones. We can pull those off. I was thinking, I think the lights even are on the same line. And if that's the case, we should change those too. Oh yeah, these lights here should all be on a different line, I think. And that alone will probably give enough bandwidth to be fine. Let's see. So we can start with that. Let's change, since this is all inside the base. These whole lights are on a single line. It runs to here and connects with nothing else. So we could just like clip this one spot. That should turn off all these lights without affecting any other machines. That's a good start. Let's see. Should we just throw down another one of these guys, maybe? Pretty easy to just do something like this. Just want to see what's going on here. Let's just give it a full line. Your new line. Congratulations.
Jetpack critical.
So that gives us a lot of power back right away. That might be all we need. Let's see. Jetpack go here. Jetpack go here. Power go here. Okay, so what is that? 1, 2, 3, 4, 5, 6, 7 lights? And they're like 50 each, is like 350 watts, something like that. This alone is probably enough. But let's pull a little bit more power off that line. When the storm clears, we can tweak the outside a bit, and I need to fix wherever we burst the line. There's something that's wrong out there. Alright, so we gotta wait for the storm. This needs to be fixed. And I want to turn this off for a second. Let's be careful with the auto furnace. Maybe do a little programming on it even. Alright, let's see. How'd you like Storm Update? I like Storm Update. Storm Update was fun. It's a good... they improved it. Looks much better visually. Doesn't make as much lag. Big fan. I like the expansions and whatnot. I feel like the performance got a little better too. A lot of good updates coming out recently. Okay, so what are we looking at? I wanted to look at a couple things here. So this is the logic for our auto furnace. And I was thinking about it a bit, and I was thinking about some things that we might want to change. Some minor changes that would be helpful. Let's see. So first off, I'm looking at the... let's see... I have the bar at the bottom. Thank you. Let me fix that now. Oh, that made it so much worse. Why? It's only this game. That's strange. Let me reset that again. There it goes. Thank you very much for letting me know. That annoys me. That's made it into a bunch of videos. Much better. Okay. So I was thinking we could probably clear up the logic around completing recipes. I think we can delete a lot of it. And I think we can reuse some of it. So I'm going to take a quick look at this. We've got a stage for, it's called completing emptying. There's stage emptying and stage completing emptying. We basically have two processes of emptying and filling based on if we're doing it in the initial phase of trying to just melt everything or the completing phase of trying to shoot for target pressure and temperature. So this is the one where we're shooting for our target pressure and temperature. And the first thing we're doing is we're branching away until the ingot is ready. And then when the ingot is ready, we go to stage completed. Stage completed is going to open the furnace, sleep for a couple seconds, close the furnace, wait just a teeny bit of time, turn off some stuff, go to stage idle. Okay. So what I was thinking is that this shouldn't be stage completed. This is stages are if you're in a stage like waiting for a certain condition where you need to be cycling and checking variables, looking for some sort of break condition into doing something and moving on to the next stage. So this isn't really a stage. When we're ready to complete, the moment we're ready to complete, we should immediately just walk through the action of completing. We're not waiting for anything. Just like pull the chute, do all that jazz, and then move on to stage idle. So I'm thinking I want to refactor this just a teeny bit and change this from being staged completed to check completed. And check completed is going to check if ingot is ready. It will branch if equal to 0. The ingot is ready. Raw. So check completed is expecting some return address. We're going to call it with JAL, which will push a return address. The first thing it's going to do is it's going to check if ingot is ready is equal to 0. So this is a Boolean 0 or 1 based on whether or not the thing is completed, if it's ready to print the ingot. So if it is not ready to complete the ingot, go to the return address. If we are ready to complete the ingot, then let's go ahead and keep moving. We're going to open the furnace, we're going to sleep, we're going to close the furnace, turn everything off, jump to main. We'll do all the logic we want to do for handling the moment we're completed. Along with that, we want to handle, this could be called during different functions. It could be called when we initially enter the completion process, just like, I think there's like a completed stage we might need to look at. Anyway, it's called during the filling stage, and it's called during the emptying stage. So we want to be sure to turn off the pumps and turn off the dials for input-output on the furnace. So let's just do everything involved in the completion process right here. And then we should be able to delete some code above. So that's going to be turning off the turbo pumps, which can also be, instead of set by name, we'll just set all turbo pumps off, set them to 0. We'll set the input, output, both furnace input, furnace output, all get put to 0. Oops, my bad. So we check to see if the ingot's ready. If it's not ready, we'll go right back to whatever we're doing. But if it is ready, we turn all the pumps off, we turn off the input, we turn off the output, we try and freeze it in the ready state where everything's perfect and we're ready to print the ingot. And then we immediately open the thing to print the ingot. There's no delay, there's no yielding, we're just immediately freeze, open the thing, do the thing, sleep for 2 seconds to let everything exit, close the furnace, give it just 1 second to complete that process of closing, and then go ahead and turn off the flashy light, reset the stack, move to stage idle, jump to main. Okay, so this is a better function. And when we are looking at our, for instance, this portion where we're checking is the ingot ready, then go to stage completed. Otherwise do some stuff. This should just be, we can delete all this and just say JAL check completed. It's going to jump there, check to see if it's completed, and then if it's not, it'll come back up here and do whatever it was going to do. Same thing for all the places where we were doing any sort of logic. Like this portion right here, the completing filling is checking if it's ready, and then it manages turning stuff off and changing the stage and all that jazz. So we can just like delete this and change it to JAL check completed. So this is removing complexity and repeated code. So now we go to JAL check completed. All these stages are going to initially, before they do anything, they're going to jump there, check some stuff, come right back here and continue running. Unless it's completed, and then there's no point in doing anything at that point. Turn everything off. And then do all this jazz. And along with this, we want to do one more thing here. We want to open the input all the way. The input is supposed to be open. So let's grab this whole line, throw it here, set it to 100.
Hydration critical.
Okay. That's good. That's a start. Confirm. Drink. And I was thinking I want to change the storage format I have for the memory. Let's see. So if we look at our code in our furnace, we're given two pressures, and then we compute a target pressure, where we have basically a pressure minimum and a pressure target, which is kind of like our maximum that we're going to expand to. So we kind of have 3 variables for pressure here when we really only need 2. We should have max and min, and I was kind of thinking of the memory wrong. In the memory where I'm defining the ingots here, I was thinking of them as like an object where you define all the properties of the ingot for like its max temp, min temp, max pressure, min pressure. I mean, that all is just part of figuring it out. I think it's better to not define it with its own properties, but define it relative to like the furnace. It's the min pressure you want the furnace to go to. It's the max pressure you want the furnace to go to. For temperatures, it just needs one temperature of what's the target temperature, because the furnace is going to be alternating hot and cold air to just try and achieve whatever target you want. So I think we can simplify the logic here and more like tightly control the furnace. It's more directly translating to exactly what's happening in the furnace. On top of that, it deletes one variable, which is important when we're repeating that object for every single one of these guys. That's going to be like 10 or 15 lines of code. And this guy only exists to save code because we can't fit that all into the mall manager. So having a more correct thing that takes less memory feels like a good idea. So let's take a look at that too. What's that going to look like? First off, we're not going to be doing this weirdness of computing either a target temp, where we're like dividing it by 2 for temp high, temp low. We are going to have press high, press low, but basically press high is it is exactly what it is. It's the high pressure, low pressure. Those just directly translate. It's no longer the high pressure, low pressure of the ingot. It's the high pressure, low pressure of the furnace. So we can just change the way we're thinking about it and not even tweak the label. In fact, the F press low is like furnace pressure low. This is already saying that. Okay, anyway, we'll delete logic for pressure. There's no more target pressure. Target temp is not something that's computed anymore. Target temp is loaded. And where is target temp loaded from? We're loading temp high, we're loading temp low. There's going to be no more temp low. It's just going to be temp. Or even F target temp. And then we'll load that into the target temp. Okay, so tweaking the variables, which means they're going to need to be deleted here. There's no more target pressure. It's min pressure, max pressure. There's no more min temp, max temp. We didn't keep those. We were putting them in R and deleting them. So far so good. Let's double check the variables. 15, 14, 13, 12, 11, 10, 9, 8. That is how we count. Stage completed, I think, has disappeared now. We deleted stage completed. We turned it into check completed. We can see that up here. Stage completed doesn't line up to anything. So we're actually going to delete that stage. That's not a stage. Let's get rid of that. Alright, we've changed the variables we're loading slightly. No more funny math, just min, max, target temp. We need to change the name of these. First off, one of these can disappear. This guy can go. You are target temp. Your name is now F target temp. Okay. I think you're powered off, right? So wire blue back there. Can I see that? Look at that. There it is. Yeah. There's probably more stuff we have to fix outside. Let's finish programming though. Let's see. What are we doing? Just changing those variable names while we got it in the brain. Then we're going to need to change it in the other program as well. But that shouldn't be hard to do. Okay, so we've swapped out the variables here. Now they're being accessed somewhere else. They're actually being used. So we need to see where that's happening. And we could probably just like throw the chip in and see where it fails. Because I'm guessing it's going to be trying to access variables that no longer exist. It'll just give us an exact line number. But where is this? This is in completing emptying, completing filling. Let's see. So filling is going to go to not target pressure. It goes to max pressure. I think that's it. Okay. Other than that, nothing else really changes here. We're good to go there, I think, for tweaking the format of the memory and changing the way we're completing to go faster with less repeat code. Let's see. Just thinking, anything else we want to do here? What about the stage completing, I think? We still have like a stage completing. What does that even do? That just goes to stage... No, I'm looking at the wrong one. Where's stage completing? Stage completing. Stage completing. Oh, yeah, we do want this actually. So this is called right as we're transitioning from doing the smelting phase to doing the, like, looking for a target temperature phase. And so the first thing it does is empty all of the air for 10 seconds. So just get rid of all the air and then start trying to put it into the target temperature. So this is a good phase. We don't want to delete this at all. This is good. Alright, I think we're good here. There's likely some errors in this code already, but I think this is generally a better direction. I'm going to throw that in and not use it yet. We need to change logic elsewhere. Let's see. You are the memory dude. Memory is now changing. This is our memory. We are representing every... Oop, ads are coming. Oh no. Ads. I'm gonna grab a drink real quick while ads are running. 1 second. Alright, we're back. Let's see. We were looking at memory. So I was saying this memory is how we manage the furnace. It is basically just, it's the stack. It's just a stack of integers. And it's like every 7 or 8 integers represents one item. So the item Constantan here is labeled as the first in the stack, and then it has its requirements. It needs 10 stacks of nickel, it needs 10 stacks of copper, it needs 0 stacks of any third element. It has max temp, min temp, max pressure, min pressure. So all we need to do here is we need to change the temperature. It's not max temp, min temp anymore. Now it's just the one for target temp. And what do we want our target temp to be here? 727's no, the 727 is the bottom temp, so that's going to be a bad one. 727 is like right on the edge of what it's possible to print at. And it can go to, what was it, 3000? It can get really hot. So we should pretty much just do whatever the temp of our hot air is going to be, or like we could do like 1000. Our hot air is at like 2500, so it's just going to mix the hot and the cold with probably mostly cold. And then that'll be fine. But this is going to shoot for 1,000 degrees, which will work. Okay, so we just need to do this a couple of times. We need to look through the items. We need to see what is their high temp, low temp. And then we need to delete one of them and decide what temperature do we want this out. I think 1,000 in general is a good, like, free temperature, basically. Like, minimum cost on the system. And very safe to print at for both of these. Same story for steel. We're going to do 1,000 here as well. And that saves 3 lines of code. Now everything we do is going to be 1 line less, which is nice. Additionally, we need to change the scaffolding where it pops this into all the various memories and displays. We're going to tweak it super slightly. Instead of having the temp high, temp low, we're going to just have the target temp. So we delete one of these and then match the structure that we just did below. And this should be it. We already taught the furnace to read this. This teaches the memory to set the right thing. This should be good. We're going to export that. We're going to save it. This is our recipe, or furnace recipe memory. Confirm, export, throw it in. Okay, so that's the start. We've tweaked the programming, cleaned it up a little. That's a good fix. Now we need to fix the broken wires and probably save some power. We already saved a lot by putting all of these guys onto a different line. Let's go outside and put some stuff on a different line out there as well. And I think we burst some lines out there, so we need to fix that. Also potatoes. We're now potato poor. We're on to the last potato. I mean, we have infinite potatoes, but I gotta click on them, and it's a lot of clicks.
Oxygen critical.
Did you get nitrogen supply you needed? Sorry, I missed that. Nitrogen is... We're working towards it. It's kind of hard to gather. I can check on stuff. Just as we're playing, we are generating some nitrogen. This line is filling up. It's up to 5.69 nice megapascals of nitrogen. So just as it's processing the gold and whatever else we throw through our system, that's getting added to the nitrogen line. I was thinking I want to swap out the whole nitrogen line. I want to pump it into a storage tank over here, or even into the liquid system and start condensing it. But I want to move it into our nitrogen cooling system so we can get that going. And I want to swap out the coolant line with oxygen, actually, since oxygen can get colder without freezing. Without condensing and turning into a liquid in the pipe and causing issues. I want to swap out our coolant supply for oxygen instead and put that nitrogen into the tanks. So that's the thing to do. But first I want to make progress on the mall and get it cooking. And along with that, if we fill the mall a bit, then that's going to generate a ton of nitrogen to add to the line. So let's let that do that and capture all that nitrogen. Anything we mine goes into the nitrogen filter. Anywho, let's see, what did we break? First off, I was thinking these wires can be adjusted. We should save, but should be safe to enter this. Let's try and move whatever power we can into a new line. Just try and like keep minimum power. We'll need the automation line, but we can move power to being some new circuit for all of these pumps, these 3 pumps. We might not even need the fuel pump anymore. I think I'm going to take that. And then also even the furnace. The furnace can be adjusted. The power here can come from something else, something better. And what's this circuit? Are you on the same? You shouldn't be. Okay, you're on a different one. So already we've got this line right here. This is coming off the main line. We've got a circuit that just goes to like 1 fan, 2 fans. I think just like 2 fans. That's not connecting with stuff, is it? I don't think so. We could check. Let's see. What's your network code. You are 996 for the last digits. The furnace and stuff is also 996. Ooh, okay. So that is more power we can save as well, I think. This whole guy should be on a different circuit than, like, the furnace and stuff. Interesting. Is that where the power for that whole line comes? I don't think so. I think I've got another... It might have two transformers, is what's happening. Might have a transformer here and another one there, which would help explain how the thing would short-circuit and explode instead of just, like, reaching maximum usage and flicker off. Okay, so I think we want to separate stuff a little bit. Just thinking out loud here. Let's try and break this into a couple circuits and put all of the power, like this guy and these guys, put that onto a different line. I'm thinking this line right here, we disconnect it right here. And I don't even think that's going to turn off anything inside the base, because I think I didn't realize these were connected. This could help, though. I cut you. And we'll work out with, or we'll work with whatever consequences that has, but I don't think it'll have any. Okay, so here's one line. This one just handles the outside, like, natural air generation. Or gathering, I mean, for generating air in our hot tank and cold tank. It's got the logic for that. It also powers this guy, so this is nowhere near capacity. We can easily plug in the pumps and the furnace to this guy. That alone, plus separating this guy from the line, is probably going to generate all we need here. That'll be a lot less power on the circuit that was overloading. And I'm pretty sure we were, like, right on the edge of where it overloads too. So we don't need to do much here. Hopefully this is overkill. Okay, so furnace now has power from a different source, but automation from the same. Let's do the same for these guys, and I think I want to just totally remove the fuel line. We don't need fuel. How's the hot tank doing? Hot tank is at 44 megapascals at 2400 Celsius. It's ridiculously hot. All of the heat we generate from producing water is immediately dumped into the hot tank. So it's kept in sync with like fire already. So I don't think we're ever gonna need the fuel, and if anything we might just like plug some oxygen into here. If we put a little bit of oxygen into the fuel tank here, it's 50% volatiles and it's really hot. So it'll immediately combine with the volatiles and combust. Like, we don't need to put fuel in here. We can just put oxygen in and it becomes fuel. And then it gets extremely hot. So if we want, we could just say, you know, if the temperature is below 2000, throw some oxygen in. And then this will always be hot enough to do everything. But I don't think we're going to have any issue with running out of hot air here. Anyway, looks good. Overthinking likely. Let's take this guy. Okay. Power for both of these is facing the same way already. That's great. So these are easily adjusted too. Let's just clip this bottom portion. And then these can go out this direction. And connect to that new circuit. Ooh, yeah, we good? So those have power now. Okay, they have power. Automation has not been touched. Nothing changed here. Did anything, like, blow? Can I see any broken lines? Or are we okay? I know there's one missing line up there. Where I put a fuse and it immediately just burst. Not seeing any broken lines here. about up here towards our mall? This is all on the same circuit. That's the one missing line. I believe. Or there's one like right there. Okay. Am I trapped? This is my prison. We're good. I think that's all looking okay. Let's see if we can turn stuff back on again. And see if it works with the new programming as well. I opened these all up. Let's make sure they get closed. Seems good. Home. Alright, what are we doing? We got one last line here. And then some stuff should turn on. I'm already seeing you're powered, right? Where is that coming from? Not there. Where do you get your power? You're connected to all sorts of stuff. From right here, I think. Nope. Definitely not right there. Up. Okay, so you're connected. You're not, I think, right? Yeah, these are off. So do this guy. Looks good. And then did I make more fuses? I wanted to do some fuses. Give me one fuse. 000, yeah, okay. Let's put on a fuse in case something goes funny. Are we still good here? I think everything's good here. This has already had its name changed. It's got the right value. No. Yes? No, this has the high value. Ooh, okay. Let's see. Here's what I'm gonna do. I'm gonna save just in case something goes funny. Can I rotate? We need to rotate back to Constantan. So let's force, I'm gonna do a reset on the opcode. Does that reset to steel? No, because of you. I think I need to... like manually set the setting on this one somehow. Basically all I'm thinking is it's gonna have the wrong values in the program. And if we rotate, then it's gonna have the wrong values in the counts. It's gonna think it needs to put in 10 of everything. It's gonna put in the wrong or extra stuff when we don't need any. What do I do with you? Is this even right? I think I hit the wrong thing. I thought these were pressure. I did the wrong ones here. Whoops. Nice. Alright, we got immediate problems. I'm feeling like I just need manual control over the furnace. Maybe that's what we do. I'm gonna take manual control of the furnace. I'm gonna finish this recipe myself. I'm going to get the furnace cleared. We can correct the pressure temperature thing. We can rotate through memory and get everything to reset properly. Yeah, that seems fine. Okay, so first off, you can be corrected. You are supposed to be F press. High. You are supposed to be F press low. So now these will line up. You are the target temperature, right? Target temp. Okay. This should be relabeled. Press high. You are. Press low. Okay. I think I have the chip with the old programming. I don't even need to like do anything here. So I can take this guy, throw it in there. I think this one does the furnace. Okay, I'm gonna save. Do you run? What are you angry about? Line 28? What are you mad about line 28? Because I took away your fuel thing? Is that what it is? It's time to debug some code that I'm about to never use again. Line 28, what's wrong in line 28? Show me. First off, did I save this? I hope so. Maybe, maybe not. I'm gonna overwrite it just in case. Even though we've already got it in memory up there. Import, edit. 28 was it? 28 is set the fuel pump on. The fuel pump is on. I'm just gonna mute that guy. And maybe even mute that guy. Export. No fuel pump anymore. You good? You running? You do the thing? Okay, so this gives control to the old program we used to use to run the buttons, which should be working, I believe. We got output dial, we got input dial. Okay, so you should be a 10. Can we? I'm gonna save. We should be able to take some gas in. Good. We can do the activate button. We can craft. What is this? I'm making Constantan, which has 20 megapascals, basically any temperature. Okay. So 20 megapascals. Let's give it some hot. Maybe give it a little cold. Maybe give it a little more hot. Just waiting for 20. We've got the activate switch, so the moment we hit the correct conditions, it should pull the thing and empty the furnace, load it all into the system, goes into the mall. Okay. Done? You good? You go here. I'm done with you. I'm gonna put you in the corner just in case we ever need that again. We've also got the code in here, so it doesn't really matter. You can go... Let's turn this off. You can go here. Don't want to turn that on yet. I think I can just... I'm gonna save, but I think I can just turn this off and it'll start rotating again. Is that true? Yeah, it goes to steel, starts going. Okay, it doesn't need to make anything. So it's not gonna stop on anything, but it is rotating through them. We've got our pressure high is now in the wrong units. Whoops. Did I set that in the memory code? Where did I do that? Let's take a look. Where's my notebook? So everything's good here. They've just got the wrong units. And I actually want that to be correct. You go in and edit. What do we got? In the top, you are setting the modes. Okay. So we don't have this anymore. It's just target temp, right? So let's do that. The pressure high, pressure low should be correct at 14, I believe. How's that? Is that going to give us the right units? Pressures in pressure units. Target temp is the correct target, which is like 1C for all these, or 1K is fine for all of these. Or are you not updating properly? Let's make sure you're updating properly. Let's take a quick look. Did I do 1000 for all of them? 1000, 1000, 1000. Fair enough. Okay, well, so far so good. We need to test the furnace code. In order to test the furnace code, we need to feed it things. In order to feed it things, we need to teach the memory more things that it can cook. So let's just kind of like walk down the line and start making stuff. What do we got here? Which is this invar? We haven't done invar, so let's do invar. I'm gonna grab this, throw it in. We're gonna edit. We're already on the right program. We need to add invar, and we should always add at the top. It's gonna walk through the stack this way. It pops off from the top down. So we want to start here at the very beginning of the stack and add something new. So we're gonna add invar. That is gonna be called the invar ingot, which is the name of the hash for the item and also the vending machine that it lives in. Invar is made out of what? Invar is very specific in its temperature and pressure. Okay. It wants iron and it wants nickel. Okay. So we will say nickel. We'll say 10 stacks of nickel. And then we'll say iron. And we'll say 10 stacks of iron. And then there's no third ingredient. So we'll push 0, 0 stacks of nothing for the third ingredient. We need to follow the exact same structure in memory. So push those zeros. Then we have temperature. What is our target temperature here? It is 900 to 1200, so maybe like 1100, 1050, something like that. Push. Let's do 1075. Sure. 1075 Celsius. So that's the target temperature that it's going to shoot for. The pressure is 20 or 18 to 20. So the pressure top end is 20,000. The low end is 18,000. And that should be everything that's required to make the invar ingot. It needs nickel, it needs iron, it needs 10 stacks of both. 50% for each, right? Yep, that'll be 1,000. It needs no third element, this temperature, this pressure setting. This should be all we need. Save it into the memory, confirm, export, and test. Is this gonna work? It should add invar and start demanding things. Let's see. So it starts rotating, gets to invar, turns on the light, sees that it needs these things, starts shipping them down the line, runs out of nickel, which is a case I wanted to run into. What happens when we run out of resources? It should push everything through until it no longer can, and then it should relieve control of the chutes and just chill. When are Oni streams? Oni streams are probably after Stationeers. I gotta finish or get further along this run. I feel like they both scratch the same itch. I don't have time for that and Battlefield, but I do love that game, and I want to play more of it in the future. So sorry to make you wait. One of my favorite games, for sure. Okay, so, this was a use case I wanted to test. We've already seen what happens when it has all of the materials that it needs, but I wanted to test the case of when it is not able to distribute any more materials, so we can see it still needs 9 nickel, but the nickel machine is at 0, so it can't move anything through. However, we are still seeing it think that it should be moving stuff, and it's taking control of the chutes, and then I think it's giving up control of the chutes. We can see that, but then it's taking it over again and again and again. So it's doing something off. If we mouse over the state, will it tell us about what it is doing? Do you tell me your stage? You do. 2, 3, 4.
Jetpack low.
2, 3, 4. Okay. So it's going through stages 2, 3, and 4. I wonder what that means. Ooh, is that gonna mess with stuff? Likely. I might have to manually finish this one as well. Interesting. Okay, well that's fine. We're debugging. We're getting there. Import. We are seeing 2, 3, and 4. What does that mean? What are 2, 3, and 4? This is the mall manager. This is doing... It loops through all of the stuff in the memory chip that we were just playing with. And it checks each of the vending machines and sees if it needs anything, and then sends stuff and like sets the recipe. Okay, that's a good enough explanation. Let's leave it at that. This is a tricky beast. Let's see, 2, 3, 4, 2, 3, 4. It's going to fill idle, request shoots, fill filling. Okay, so it's still in the fill loop, which is correct. Oops, I'm looking at the wrong one. Stage fill idle. Okay. What are we doing here? So first off, we are taking input count 1, taking input count 2, taking input count 3, adding all of them together, saying branch relative, if not equal to 0, 3. So if this is greater than 0, then jump 3 lines to here. And then otherwise, if it is 0, then go to stage idle. So once everything has been added to the recipe, once you have managed to get all these counts to 0, then go ahead and back off and go to stage idle and just wait. So that's that logic. Otherwise, if we still like currently where we have 9 on one of the dials, then it's going to go here. It's going to say branch if not equal to 0 dial setting. So it makes sure that nothing is using the dial for the shoots currently. Okay. Add machine quantities until 1 is available. So we set 0 on R0 as a temp value. We load input hashes 1 quantity into 1. We add that to 0. So we're just keeping a tally in 0. We're loading the number of things in the machine, and then we're adding it. Okay, I see. So the problem here is that we are doing this right now for all 3 machines, which is currently hitting not only the nickel machine at 0, which can't do anything. That's the only one we need right now, is the nickel machine. But it's also hitting the second one. So it's checking the iron machine and seeing that there's stuff in there and thinking that, oh, okay, we've got stuff. So we're good to take over the chutes, takes over the chutes, runs through the logic of dropping stuff. It can't drop anything, closes the chutes. Okay, working as programmed and not as intended, but that's the bug. I think that should be a pretty easy fix. We've got a bunch of lines of code to spare. Let's see. So we only want to do this addition if we still need this thing, right? So we want to take input count 1 and say branch relative if equal to 0, input count 1, jump 3 lines. So if input count 1 is 0, then don't add input hash 1 to the thing, because we're done with that one. This is the current edge case we're running into that's not working. We do this for all 3, and then we just do input 1, 2, and 3. Okay, so now we're only adding these if we still need this material. Otherwise, jump 3 lines, 1, 2, 3, and keep going. We wouldn't be here if it wasn't for one of these things being more than 0. So this should do it. Okay, this is our mall manager. Mall lights. Crafter controller, pollution, hanger, mall dial, mall manager. No, is this the mall manager or is this the furnace manager? Ooh. Fuck. What are things named? Because there's a furnace manager too. I think I need to check. We need to be certain here. I'm pretty sure this is the furnace manager. It's managing sending stuff to the furnace. The mall manager is managing sending stuff to the crafters. like managing the mall's inventory and distributing that to crafters. Vague naming. I'm gonna be. Ooh, actually, I don't care. We're just gonna go for it, dude. Let's fucking go for it. No, I'm too scared. Okay, I'm gonna call this backup Asdiff. Let's double check. I'm pretty sure it's this one. So let's overwrite the furnace, or where is it? Not furnace recipe, furnace manager. Overwrite the code. Let's take a look at this and make sure it lines up. Yeah, that's the same program. Okay, so you overwrite. Let's get our new code back. You overwrite the furnace manager code. This is new furnace manager code. We delete our backup. We confirm. We export. We take you. We throw you to here, and you no longer suck. Your stage is wrong. You're gonna be an idle stage. Yeah. That's all fine. So we need to farm more nickel. And then we need to shoop it in manually. And then we can run the auto furnace. Are you already running? No, you chilling? Yeah, okay. Yes, and all of these values are correct. Got it. Okay, so everything's good. Let's go farm a little nickel and then see if the auto furnace works. Yep. Good on food and water. Need a drill. I don't think I'm feeling like slow to leave the house. I feel like I haven't gone out in so long. I've been programming for like 10 hours. Spent a lot of programming. Feels weird moving away from base. I forgot to check what we need. I should have looked at the lights. I know we need nickel. That's mostly what I'm interested in right now. Nickel, please. Are you nickel? No. Get away from me. Oh, I'm greedy. I'm too greedy. I want all of it. I don't even need all of it, but I want it. Oh, nickel. Alright, that's 3. More nickel. I feel like I definitely need to work out more ore production as well. I shouldn't be farming by hand this late into the game. Need those rockets. There's one bag. Probably 4 or 5 stacks of nickel. You need lead for solder pretty quick here. Alright, let's get a little more nickel. It's a lot of nickel. It's probably enough nickel. Okay. Oh, it's a whole nother thing of nickel. I gotta get it. It's too juicy. It's right here. I'm clicking on it. You can't stop me. I love nickel. Let's grab some of that lead too. Ooh, I'm excited. This might be it. It's getting super close. We're just working out the last little edge cases. Make sure it runs smoothly. Make sure it can do all the recipes. Find any strange bugs. But I think it's all looking real good so far. It's working very smoothly. Alright, I think this is probably good. Where are we? Where's home? Right over here. All right. Time to process those resources. In you go. Turn into things. Pretty sure this is empty. Throw it in anyway. Potatoes. Potato time. Potatoes are good. Just doing a couple potato chores. Make sure we got food. Alright, so all of those materials got thrown into the auto furnace. And we can see the belts coming out on the other end as they get emptied and sorted and smelted. So the nickel should enter the system in just a moment, and we'll be able to move it into the furnace. How we doing? Everything's pretty low? Except these two, since we have infinite. Nice. Need Invar, we're working on it. It's all on Invar, it's all good. Okay, so I think we're totally good here. I'm gonna save for no reason, maybe? Can you turn on and run? You should be pulling all the right stuff. You should get to the correct state of... not state 1. Not state 1. Are you the right code? State 1 is the idle state, I believe. It should be in the state where it's smelting, since it has reagents. What you thinking? Are you the right program? Is this auto furnace, or is this the furnace with the buttons? This is definitely the auto furnace. Stage 1 is stage smelting. Oh my god. Alright, let's I'm gonna tweak this. The stage idle. First off, you should be hard-coded to stage idle. We're gonna change stage idle to stage 1, because it's throwing me off. Everything goes up 1. These no longer start at 0, they start at 1. Okay. So stage 1, 2, 3, 4, 5, 6, 7. This is our advanced auto furnace. Overwrite, save, export. Go here. It goes to 2. Smelting. So it's in the smelting stage now, where it is trying to melt 1,000 stuff, and it's maintaining a minimum temperature, which it's way above. So it's doing nothing. Just waiting for resources. We need 9 of the nickel. Okay. I'm gonna do 8 and 9th in a second, maybe. Here's our nickel. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm gonna save just in case, and we'll do the 9th, and that should kick it into the complete recipe. It'll get to 1,000, and it should enter the later stages of shooting for a specific temperature and pressure. First off, it'll hit 1,000. It should empty for 10 seconds down to like no pressure, and then it should fill, alternating between hot and cold, shooting for the target pressure of 18 to 20. It's just going to be like hanging out in that range, and the target temperature of 1.08 thousand Celsius. Here we go. This is going to do the thing. We hit 1,000. We depressurize. How are you dealing with Mr. Missile spam? I'm doing this. Mostly. Okay, now it's filling to target temp. We can see it alternating between hot and cold. It hits the target. It lets it out. It's done. It resumes the process of doing the things. Nice. You should be a 0 now. Okay. And then it's demanding control and doing stuff. Nice. Awesome. And it's still got 1 to go. So we're at the exact same use case, where it still needs nickel, but it has enough iron. Is it still going to hold the chute, or is it going to relieve it and leave it? Now it's leaving it until another nickel comes through, which may not happen. We might need... Oh, there it is. Now it should take it. You doing the thing? You clicking the button? I can't see. I might have clicked the button already. Did you do it? I don't see anything shooping. Did you do it? Are you gonna do it? Come on, do it. Come on, you're thinking about it. Why? Bugs? Probably. Come on. Okay. So we might need to look at the code here. I am wondering, just thinking, what is it doing here? It's taking control, thinking that it has something to add. Let's take a quick look at the code. First off, what's this program? This is our furnace manager, which is up at the top. Let's go ahead and load that one. So it is... It's getting to the stage idle fill here. It is correctly... Now, it is correctly doing these branches of like, this is the bug that we fixed. It's correctly doing this. We saw it doing this, where it's actually seeing that the quantity exists in the machine for the ones that it needs. And this means that our input count 2, at least, is accurate at 0, since it wasn't triggering this add here, adding the quantity of our iron to the machine. So this is all working relatively correctly. It's only requesting if it can request. And then when it does reach that point, it goes to request chutes. and turns it to dial 1, which it is doing. That's working, that's working. It's going to go to fulfilling. It moves num requested 0. What is all of this repeated jazz? I feel like this should be some sort of helper function or something. But what are we looking at? Let's think about this real quick. So move num requested to 0. It loads the number. It sets it greater than 0. So it's just like turning it into a Boolean. Is it greater than 0 or not? And then it does that for the input count as well into R1. And then it ands those together. R0 and R1 go into R0. Branches 5 here. And that's going to be 1, 2, 3, 4 to right here. Yep. Where it's then going to load the next one. Okay, it's loading input 2. It's setting greater than 0 again. It's just following the same pattern. Input count 2, anding them together. Branch relative if equal to 0. So just looking through this, trying to see if anything jumps out is incorrect. Let's see. I guess we could check the last branch. This is loading input hash 3, set greater than 0, set greater than 0 into R1, and together for input count 3, branch relative equals 0. Okay, so is there any issue in the bit that we're branching over? What's this gonna do? So we enter this section when we know that we have something in the machine, and we want to, and we have an input count that's greater than 0. So we want to be adding 1 to the machine. So both there's something in the machine and we want to add 1 to the machine. And we're jumping into here. We're subtracting 1 from the input count. We're telling it to vend the hash from the machine. We're adding 1 to the num requested, which is just this guy up here. We're keeping track of the number that have been requested with every loop and making sure that we keep running as long as something's being requested, so we can click the same button over and over if we need to click it 9 times. Okay. We update the hash, or sorry, we update the console with the input count to have the new input count. And that's the end. It's just those 4 lines. So that all seems correct. That all seems reasonable. We can look for like anything funny going on here, but I don't think so. Input count 2, input count 2, input hash 2, input hash 2. Number requested gets added 1. Set the input count 2 as input count 2 now that it's 1 lower. Input count 3, input count 3, input hash 3, input hash 3. Number requested gets 1. Input count 3 goes into input count 3. That all is looking pretty okay. Alright, so what is going on here? How are we incorrectly leaving the fill idle stage? No, it's not even that. We were getting through this correctly. It's that we're not clicking the button correctly. On the second pass, though, seems significant. Like, it did it correctly for the first iteration through this section of code. It did as much as it could, and then it correctly went back to here. And then, when it comes back to stage filling again, we can see that it's going there. I think if we take a look, we'll see that it gets to fulfilling 4. And I remember it's going 2, 3, 4, right? We can look at that. Should be doing 2, 3, 4, 2, 3, 4. See, it's in 4. It's in stage filling. So it's getting to stage filling and it's not clicking the button. Why are you not clicking the button? Why do you not click the button? Don't you want the nickel? You're recognizing there's nickel there. You're recognizing you can click the button. You're taking over the chutes to click the button. And then you're not clicking the button. Are you going back? Let's double check. Are you going to stage 2, 3, 4? Okay. What you thinking, guy? You're very close to working. But you're not, though. Is this even the right? Yes, okay. Two, three, four. Fill idle, request chutes, fill filling. So we're getting to fill filling. And we're not correctly branching to drop the, or to dispense from the vending machine when we know that we could and we know that we need to. What is wrong? Something in this section of logic is going funky. In particular with the input hash 1 is the one that's not working currently. So we can be relatively confident it's something in this chunk for input hash 1 that's just not mathin' right. Something is off. Who's smarter than me? Who figured it out? Anyone know? No? That's okay. There have been many bugs in this adventure. I bet we can defeat this one. Oh, I see it. Oh my god. Amazing. I thought that's wild. Brains are crazy. It's this one. This is supposed to be checking for input count 1, not input count 2. I thought I went over all of these. Not close enough, apparently. Okay. This was looking at the wrong variable. It was looking at, in this case, the iron one in particular. Oh, is that right? I mean, this should definitely be a 1, but I feel like this might not be what was happening. Just looking for anything else. Any 2s? No, let's call this good. Okay, so this is our furnace manager. This gets overwritten and confirmed. I'm gonna turn you off. We're gonna export that code. We're gonna put it in here. I'm gonna manually finish this one. And then we'll have to test it some more. Okay, so that's another bug down. That's good. That explains why that wouldn't be doing that, perhaps. Are you ready? And are you empty? You're not empty. Oh, but you are down to 0 is why. Ah, I see. And then... Did it even get the right ratios? It might be messed up. I don't know. We'll see. Anyway. Let's try this. Let's give it one of these. Is that going to go to 1,000? And then you're going to do your thing already. We do the 10-second empty. We start to fill to the target temperature, alternate between hot and cold, doing good. Finish, craft the recipe, let it go to idle state, turn off the lights, everything's good. Save, but we don't need to. Mall manager goes on. Wait, is this just called mall manager? Crafter manager, mall manager. And it's the furnace manager. Ooh, the naming's wrong. This is gonna be problems if we're not careful. Anyway, okay, where are we? We're rotating through our recipes. We already have enough of everything that it's been trained to do. There's enough Invar in the system, there's enough steel in the system, there's enough Electrum in the system. Let's just walk down the line. What are we looking for here? Solder? Can we do solder? Okay, let's teach it solder. Got some ads popping up. Alright, I'm just gonna move around for a second while you're watching ads. It's just hopping in circles and I'm super dizzy now. That feels kind of nice. Just shaking the human a little bit. Shake some energy back into me. Bounce in circles for a minute. I need a trampoline. I need a nice trampoline would be good. If my bedroom was a large trampoline for the floor, I think that would be perfect. And I could just bounce around whenever I'm doing things. Well, 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 hello, Neff. We're doing it, Neff. It's working. I'm just fixing the final little bugs, making sure it's all working smoothly, but it looks like it's working. It's doing all the things, and I'm teaching it to do more things. We're going to teach it to do solder right now. Let's import this memory. Let's add solder to the memory stack. And then it should be good to cook solder. Or we'll find some new bug. Let's find out. So we'll go to the very top of the stack. We're going to be making solder. Solder is going to be 10 stacks of iron. It's going to be 10 stacks of lead. It's going to have a target temperature of what? Solder is iron and lead. It's going to be 700 or 76 to 277. So let's say maybe like 100. Let's do a low temperature. So it just only ever does cold gas, and then the cold gas is like 120. So if we say 100, it's only just going to do cold, and that's perfect. Okay. Where am I? Solder goes to 100 Celsius. Solder, we're looking for a max pressure of, it's 1 megapascal, so maybe even like 2,000. 2 megapascal max pressure. Min pressure is 1,000 megapascals. And I think that's everything. Oh, nope, not quite. We've got iron, we've got lead, and then we need the third ingredient, which is nothing. So we push 0 for the hash of the third ingredient and 0 for the count. Furnace recipe memory, overwrite. This should teach it how to make solder. Let's save, I suppose, throw it in and see what happens. Should start rotating through everything, and it'll reach solder at the end after Invar. And it will hang there because we need solder. It will turn on the things, it will request some things, it will request as many things as it can request. Unless I've added bugs. Let's find out. Not a strong start. Not impressed. What's going on here? Are we out of iron and lead? I'm certain no. We've got lead here. No, sorry. Iron here. 7 stacks. Lead is somewhere here, but I know we have a bunch. Lead is here. 24 stacks of lead. So we've got plenty of both. It should be sending that along via the mall. And we are getting nothing. It did change the thing to 1. What's the mall manager? So we're at state 2. It's chilling at 2. Just hanging out in 2 forever. Living in 2. When are you gonna craft chickens? Someday. We've been avoiding food for a long time. Just been a potato farmer. May have copy pasted wrong. Maybe. This is all looking right. It's got the right temperatures and everything. So this is all correct. We're seeing the correct variables for everything. This is all right. This is right. This is right. Taking the shoots is right. Not bringing anything is wrong. And I'm just keeping the mouse on here. It's just seeing that it's in 2 forever. So I'm going to turn that off. Let's go ahead and import. Let's take a quick look. What is 2? How are we staying there forever? Stage 2 is fill idle. Okay. Fill idle is gonna add input count 1, input count 2, input count 3. Go to the idle stage. If there's 0, it's gonna set the dial to, or sorry, it's gonna make sure the dial is, let's see, if it's not equal to 0, it's gonna go to main. Oh. Is it that I just had the dial on 1? Did I just leave the dial on? Is that all that's happening here? I'm gonna load real quick from where I saved. Might be working fine. This was right as we were about to turn it on or something. Is that correct? I got a chip in my hand. I'm about to turn it on. The thing's on 1. So I think that's all the problem is. It had, the dial was locked up, which it should wait. If the dial is taken, which is me, like I want to send some stuff to the trader. Well, I'm going to turn this to 7. And yeah, it should not be taken over. This is my my input. So it's just waiting for the chutes not to be in use. Okay, false alarm. It was, I think everything was working like it was supposed to. So I'm going to turn that to 0 and relinquish control of the chutes. I'm going to save. I'm going to throw this in. Should have the memory. Should rotate through everything. Should get to solder. Should hang on solder right now. Should turn on the light. Should request things. We can see those going through the chutes. Interesting. Not enough iron? Are we out of iron? We are indeed out of iron. Good. So you should go to 0 and chill. And then I should be able to farm some more iron. And you will go into the system and finish everything. Let's see. First off, nothing happening here. You should just be chilling and looping forever and not taking over anything. This is good. So that's a bug fixed. Okay, let's go get some iron real quick. What else are we missing? We've got these useful lights now. I can just look and see how do things look. These are all crafted by the machine all the way to here. I feel like I should almost do some sort of like paint to mark that spot. Anyway, we only need to pay attention to these. So low on coal, totally out of iron, pretty much low on everything. Pretty much low on everything. Really need iron. Okay. Let's go farm some iron mostly.
Oxygen critical.
This is good. This is working. I put a couple comments on there. There's a couple of comments. I left a couple examples. I think steel's pretty well labeled. It's a pretty easy pattern. Alright, we need all the things, but mostly iron. It's working. This is amazing. becoming the fanciest base. Bad production though. Super good production line for very bad core production. Shouldn't be mining. Look at me go. This is work for the robots. I forgot to give a serious answer to the Mr. Missile question. I'm sorry. I was gonna give a dick response and then a real response, and then I gave a dick response and completely forgot to respond, which just leaves it a dick. Mr. Missile scary. So that's pretty strong right now. I'm kind of just like not playing Firestorm because of Mr. Missile. The lasers on that map are pretty unmanageable right now until they get that tweaked. Generally speaking, if you see that you're painted, you need to expect that there could be a locked missile coming in from like any direction, and you're not going to hear it. So whenever you see painted, you just need to hit the deck and try and get some physical cover between like you and everything basically. And then maybe listen for an explosion. That works pretty well. There's good cover on most maps, but Firestorm in particular is pretty brutal. There's a lot of good vantage points to give Mr. Missile super easy kills. Mr. Missile's strong. I'm also sure that the Battlefield player who asked this question was more than likely not interested in sticking around for a bunch of station years. But let the record show that I did provide a real answer eventually. I didn't just end at the dick answer. Sorry about that, whoops. Alright, just doing some big farming. Still gonna need a lot more iron, I think. It's about time to remove all of the controls from the furnace. That's fun. I'm gonna be totally done using the furnace. That's exciting. This is like 3 levels of automation further than I've ever gone before. The whole thing. true. Let the computers handle all of it. It's all problems that a computer can solve. Better than me, actually. If you teach it right. They're much faster than I am. They can pay impressively firm attention to the temperature of a room. I could never keep up. Robot strong. Do I even need cobalt? Maybe. Probably. Everything was low. This is mostly farming for the next ingots. I think we're just going to get a few stacks of iron, and then that's going to finish up the solder, and that'll be done, so it'll be time to program the next one. It's about time to get to the expensive ones. So we're just kind of filling our reserve of all of the everything. It's all going to disappear right away. And be a little bit of farming to get everything going. Gotta fill the base. It's super cool. I'm excited. It's amazing how easy it is to teach it to do a whole new recipe. I want to see how that works with the super advanced alloys. Particularly the ones that have like a really fine threshold for like pressure or temperature. Might need some adjustments. We will see. I think that's all of them. Oh my, okay. Alright, so just bring back 5 belts full of ore. When the robots decide to turn me into hot dogs, it's all over, dude. They're much faster than me. They can make me hot dogs. Hopefully I'm delicious. What are you gonna do? Some would argue that humanity was born just so it could eventually be hot dogs for the AI. There's a good argument there. The robots need hot dogs. Okay, so we're adding a bunch of stuff to the system. We still needed 3 iron. Might need to give it a second here, but we should see that enter and then be distributed. Working immediately. Oh yeah, look at all that. That's magic. The last iron enters. you gonna let go of the chutes? You do. Chutes are cleared. Okay, so now it's on for the furnace. How's the furnace handle this? You've got 1,000, you're doing the 10-second depressurize, and then you are going to fill to between 1 and 2,000, filling only with cold gas until you can make your recipe, which you do now. Everything goes. The mall manager resumes searching through all of the various recipes until it gets to solder, which is still a little empty. Okay. I think I want to make one small tweak here. So it is... Come on now. What is this? This is the auto advanced furnace. Let's just import, just in case. Import the existing code that we're using that's working, which is the auto advanced furnace. So in the completed stage, it is... So the check completed. This is where it's actually doing the whole process of completing. Okay. And it is turning off the active light just like immediately after releasing all of the ore, which is causing the thing to start searching. The mall manager starts searching once the active light is off, so it immediately starts searching before the created resources entered the system and been sorted into the mall. So we need to wait here, and we need to allow all the ore to travel so that we don't have the current scenario where we actually have enough solder in the system, but it's just going through the pipes. Let's give it a sleep here of a while. Let's give it like 20 whole seconds. Just sitting and chilling. Let stuff get sorted and pushed through the mall. And then we'll go ahead and resume. Turn off the active light. Let it keep searching. The counts should be correct now. That seems better. One line of code there should help with that. We will set this to the auto advanced furnace. We will confirm. We will export. We will throw this into the guy. It is now going to make solder. That's okay. And it needs 2 more iron. Whoops. That's fine.
Oxygen critical.
You like the hot dog theory? I thought it was debatably too ridiculous to say. But I said it though. And now it's on the internet. Just need 2 stacks of iron. Don't need to do nearly as much farming as we just did. We do need iron. Right away. I'm not going to stay out nearly as long, but I will fill up 2 bags of iron because it goes away so fast. We're about to start making steel, just going to delete it too. Just 2. Nothing crazy, just 2. Remember, I saw coal turn to the blend-in color. We're good on coal. Go through coal super slow. Looks good. Grab a little more silicon, head out. Good enough. That should let us continue teaching the furnace things. This will be enough to finish the solder. The solder should be more than done. And then we can move on to the next recipe. Almost done with the basic ones. Time to do the super alloys, I think. We haven't done one recipe that includes 3 ingredients yet. And we're about running out of recipes that are 2 ingredients. Let's see if that works. Maybe. Probably. Okay. Oh, oops, my bad. I gotta drop off the ore.
Oxygen critical.
Okay, this one goes in. This one goes in. That's all. Alright, we're chilling. We're chilling, we're waiting for the iron to go through. Oh, it already did it did the thing while I wasn't looking. It finished crafting solder. And it's rotating through all the recipes and sees nothing that needs to be added to the system. Mall's looking relatively full, low on lead now. We're going down all the way to solder. And yeah, we have 50 of that. It did 2 when it only needed to do 1. Okay, looking good. Cool. This is working. So we are now on to the last 5. Starting, let's just keep walking down with waspaloy. Okay, what does waspaloy look like? Let's teach it. Oh, we got ads. We got ads. Oh, I'm snoozing them. Get out of here, ads. No ads. We grab the memory chip, import, edit. No ads. And we learn waspaloy. First, let's check. How are we on code? We got... Ooh. We got a lot of lines, but we have 5 more recipes to go. This could get tricky. We might need to break it into 2 programs, which I think we could do. Anyway, let's keep going. We are going to teach it waspaloy. What is waspaloy called? I don't want to spell it wrong. I'm going to copy it. We are going to paste. Waspaloy. What is waspaloy made of? It is 2 parts lead, 1 nickel, 1 silver. Okay. So first, we have lead. It's going to have 10 lead. It's going to have 5 nickel. Five nickel, and then 5 silver. We can just do this and swap it out for silver. Okay. So this is the recipe. It is going to have a temperature. Oh, the temperature is very specific. It's 100 to 527. I'm just thinking we probably want to do like 128. It's just always going to be the cold air. Okay. So we'll say push. Say 130 is fine. And it's pretty much just going to be doing the cold air tank the whole time. The pressure, that is the tricky bit. We're shooting for a top pressure of, let's say, like 52 megapascals. And then a min pressure of 50,000. So this one's like super cold, super high pressure is its thing. And that is not a problem. So we'll go from 50 to 52 with silver, nickel, and lead. Twice as much lead. Silver, nickel, lead. We got the correct temperature, which will just do the cold thing at all times, basically. And this should be Waspaloy. I'm going to save this as memory. We're going to confirm. We're going to export. We're going to save. We're going to throw this into the guy. It's going to rotate through all the things, and now it will reach Waspaloy. And probably lock up on that. There it is. Locks up. Starts dispensing. Things start moving through. It can get most of this, but it's going to run out of lead, I think. So already the next task is we need lead, and nickel's pretty low. Lead and nickel. Okay. Gotta do a little more farming.
Oxygen critical.
Good on food and water. Everything's good. Heading out. You good on battery? Yeah. Lead and nickel. Love iron. Love iron. Lead and nickel. Cobalt. Do I need cobalt? I don't think I need cobalt. Farming cobalt. I bet something wants cobalt. There we go. Trying to think how much of this are we gonna need. Might want to get quite a bit. It's like 10 per recipe. I think that's gonna make. How much is that gonna make? 500? 250? I don't really know. I suppose we'll see. I know some of these are super dense. The stellite, I want to say. You put in like 1,000 material, you get like 250. So you have to do 4,000 material to be able to reach the minimum 20 stacks. If my basic math is mathin'. It's a lot of stuff. Might not want to have it that high. Or might just want to deal with paying the one-time cost of filling it up a bit. And then we'll be set for a long time. It's not so bad too. This will be good though. When we get like a builder dude coming by, we can just immediately start shooting super alloys at him. It's gonna be crazy money. Gotta get the code for the satellite dish and start getting better traders. Get the nitrogen done. Making progress. Forget how much lead we needed. It's 10 per production. But I forget how much we flipped the furnace. Probably good to go back soon. Make a little progress. This is the last bag, I think, anyway. Nice. That's a good feeling. It's really fun to be able to make enough oxygen to get some more livable space. Just like spread out. Feels like a big accomplishment on that planet when the start is so brutal. Just like barely holding a teeny 2x1. Or whatever you start with for breathing space. Yeah, you can just grow. You just keep growing it. Got a good air composition? What's your air look like? Any water production yet? That's the big one. This is the final bag, right? Okay. This should be enough to do some stuff. Let's see what this turns into. Makes sense. I would think the plant's like 50. 40 might be a little low for plants. Can't find my front door. Base too big. I need arrows. Oops. Gotta drop off the bags. Okay. Farming done. Food and water. How we doing? You needed some lead. That should be coming through the system soon enough. And then we get to see if you can do the Waspaloy. Looks good though. All the pressures are right, temperatures right, materials are right, everything's fed in except the last little bit of lead. All the numbers line up. Just waiting for that lead. It's coming through now. Yeah, maybe. Thinking about it. Yeah. Nice. It's working. Hello, kitty. Who's a good boy? Hello. Bite my toes. You need some playtime? You do need some playtime. You make a very good argument, cat. Yeah, you can bite me in my legs. I understand. This thing's so cool. It's doing it. It's doing all my thoughts, so I don't have to think any thoughts anymore. I can just chill. I just feed stuff into the machine. Hopefully automatically sooner than later. Okay, so it got 1,000. Now it's emptying. And then it should just add cold air until it hits the desired pressure. Doing that now. Temperature's down. Pressure's up. It's got to go all the way to 50. It's doing it. Oh, it's so good. Oh my god. Uh-oh. Fuck. What? Excuse me. Do I see 1,000? And then nothing happened here? Oh, you're sleeping for 20 seconds like I told you to. Oh, yes. That makes sense. Okay, it all worked. Including sleeping for 20 seconds. Now it's trying to make more Waspaloy because it's only got however much it got. What did you get? 8? So you got 5 from that one production. Okay. We're good. Everything's good. Now it's adding more stuff. Is it running out of lead already? Are we out of lead already? We are. Out of lead, low on copper, low on nickel. Alright, let's go grab a couple stacks of things. Gotta feed the beast. Beast is hungry.
Oxygen critical.
Gonna be a little bit of farm in this stream. This is very tempting to immediately make outposts. Can't I get lead from like right here? Gold, silver. Remember, it's like barely outside of the base. I can grab lead. We could just throw down a deep miner and plug it in. It's gonna immediately be useful. Maybe a little bit, just a little bit more manual mining. It's for a good cause. We're filling them all. Yeah, that's my leading reason for getting the rocket going. I'm tempted to just do one out of fuel, just to get a scan of the planet. I want to know where to throw down outposts without cheating. But I also want to be able to automate the rocket to travel from outpost to outpost and to be able to move payloads. I want to go straight to liquid cooling. I heard liquid cooling's better. Not only for like range, but also for how much it can carry. We'll see. There's a bag full of stuff. Just looking for lead and nickel, basically. Not so bad. I think we pretty much have enough nickel already. Need like 20 stacks of lead, I think. Alright, leadware. Leadware. I think I remember copper being a little lower. Am I crazy? I can like picture it being yellow. Lead. Mostly need lead. Pretty much only lead. Lead. Lead farms fast. That guy was particularly red. I don't know why it stands out so much. It looks like ore. Just a splotch. Anyway, lead. Lead, lead, lead. I think we're pretty much done here. This is probably enough. A little bit more couldn't hurt. I'd like to have enough to finish off all the recipes there. Which is probably about a bag. A little over a bag. I think we're there already. That should fill up the Wasp Boy machine and turn off the light. Good. I'm just gonna grab a little more.
Jetpack low. Jetpack low.
Jetpack's dying. Swap that out. How's the suit? Good on air. I think the air goes down really slow. Or was that? Yeah, we have barely any waste. That's crazy. Look at that. Is that just because we're out all night? Or is it that it's chilled to like 10°C? That's way better than early game. Alright, just filling the last bag here with whatever. I'm sure it will get eaten. Is cool. Just a lot of time farming, but it's like the most effective use of time right now. And it's the only work we have to do. Do a teeny bit of farming, and the machines are doing everything right now. Where do I live? This way? This way it is. Okay, I think that's another like 5 bags full. I think I've done like 20 bags of material already this stream. Yeah, I'm with you. So if I'm inside, I'm not gonna have my suit on. You pretty much only want to have the AC gas for the outside. Looks like it's working good. So we're getting into the day now. It's like 500°C, and the tank is ticking up. Probably less than it would be. I wonder if it makes sense to chill it off even more. Battery's at 99. Battery's never close. Anyway, let's go ahead and return all of these materials. It's another 5 bags of ore for the machine. Turn it into Waspaloy all the way, beginning to end. From bag to super alloy. With the power of computers.
Jetpack low.
Alright, how are we doing? We did need a little copper. I knew it. We're 1 low. Not anymore. Just really low on nickel and lead mostly. All of them going through right now. Should come shooping through the tubes. There's a planet curvature shader. I don't know about stuff. I know if you download the custom light mod, then it looks much better. I don't know about any sort of like settings in game to make the game look better, perform better. It's particularly laggy, which isn't super important in this game. It'd be nice if it was smoother, but it's a thinking game. There are good tricks for making it look better, run better. I am open to them. That would be nice. Nice, we're up to 13. If we sit here long enough, it should go up to 18. What's next? Inconel? What's an Inconel? Gold is free, steel, nickel, okay. Cool, that one's cheap. Poor lead, thirsty for lead. This is great. I'm glad to see it working well, even on like the when everything's like super drained on that edge case, when all the machines are empty and it's like unloading them as fast as they're loading. It's still not hiccuping or getting any counts wrong. Everything's working nicely. This is super cool. Interesting. Doesn't like curved earth. I don't feel like that's ever been something that bothered me. Alright, everything's working nicely. While it's doing this, I want to go take a quick look outside. What does our hot tank and cold tank look like? I'm wondering in particular, is the cold tank running through gas, or is it keeping up with this without a problem? How you doing, cold tank? Show me your numbers. What are your numbers like, dude? You are still at 35 megapascals. You are very full. You're doing fine. Hot tank is still at 42 megapascals. It is using a little bit of gas, but you're doing fine too. And this thing only fills up to 40. So it's overpressured because it's been given a bunch of heat. And it's not adding any more hot air. But it will start cooling off too, once it adds hot air. Outside's a lot colder than 2400. Anyway, everything's looking good. Filters look good. Oh, I didn't realize. Ooh, look at that. So all this farming has added 1 megapascal. We've added a lot of thousands of moles. That's good to see. Adding a bunch of nitrogen to the system, which we can put into our nitrogen cooling system. Exhaust gas good. Oh, fuck. No. Maybe? What's your deal? Are you running? With a gigantic difference? This thing is very high pressure is what I'm worried about. Because it's loading... it's loading with 50 megapascals of cold air. And then just dumping all of that into this tank. Which empties pretty slow. This is pretty sketchy. This guy might explode. We could give it more buffer. We could. Or it could explode. That could be fun too. This is a tough decision. I'm feeling like we're not going to be making a bunch of stuff so frequently that this thing's going to explode on the one hand. On the other hand, I would like for it to never explode. I think I'm going to give it a little more space. Let's see, how does this work? You got the one thing. You just add another one right here and plug it in. Maybe paint it orange. Let's just add more buffer, and I think this is probably okay. Just give stuff more time. I doubt it's going to be running the auto furnace so much. Unless we decide to sell like 8,000 waspaloy and we're just spamming that recipe or something. Which we might want to be handling the case of, you know, pumping a ton of stuff in here. Anyway, I think if we just add a little more buffer, that's going to prevent explosions, give everything time to empty. We'll have no troubles. This is probably good for now, and I think eventually I'm not going to be pulling anything out of here. We're not going to be doing the nitrogen filtering here. We'll do the nitrogen filtering down below. Right here. These guys degas the ores as they're processing everything. So that's where we'll catch the nitrogen, is in this process. And then when it goes through the furnace and gets melted, it doesn't release any gas anymore. So we don't need to catch any furnace gas ever anywhere. And in fact, let's see, I guess if you have, there's some stuff that we could put through here which will make nitrogen. But for the most part, it's never going to make nitrogen because all that gas has been removed already from the process. It's pretty much all done ore, except the cobalt, basically. And the coal. Alright, so I'm glad we checked this. Made sure nothing explodes. How are you now? You're down to 25. That's better. Going up 26. Going up now as we're doing whatever the furnace is doing. Things look okay. Might need to keep an eye on the hot tank and make sure that we don't cool it off too much. Might need to add a script for adding oxygen if it's below a minimum temperature. We are done with waspaloy. It is no longer triggering that recipe. The machine is purple. We did it. 4 to go. In canal. Import. Edit. What does Inconel look like? Inconel is gold mostly, steel and nickel. Copy the name. How are we on space? Good. Gold mostly, steel and nickel. So the first ingredient, first we add the target hash, is going to be the target, waspaloy. Gold with twice as much, so that's 10 stacks of gold. We're going to have nickel and steel. 5 stacks of nickel. 5 stacks of steel. And that is going to be the recipe for the items in waspaloy, so that's all programmed. Now we need temperature and pressure. What is the temperature we're looking for? It is basically 300 to anything, so any temp's good. Let's use generic furnace temp. I've been using like 1,000 for generic, so we'll do 1,000. The pressure is, this is the one that's really particular, so this is the one that's likely to have some tweaks needed on the furnace. It is 24 megapascals to 23.5. So the top end is 24 and the bottom end is 23.5. So super tight range there. Hopefully the furnace is moving slow enough that that'll work. Okay, but that's it. We got the item hash. We've got the ingredients, 10 gold, 5 nickel, 5 steel, temperature 1,000, top pressure 2,400, bottom pressure 2,300. This is our furnace recipe memory. Overwrite, confirm, export, save. Throw it in the guy. See in canal pop up on the list below. Should trigger the crafting of stuff now. Fuck. Let's try that again. I didn't put in canal in here. It's Waspaloy. Furnace recipe memory, overwrite, confirm, export, throw it in, save first, throw it in, suit goes off. Okay. My bad. Had the label wrong for this guy. Did that not work? No, there it is. So we got in canal, we got the correct ingredients. It's requesting stuff. Stuff's coming through. We should have enough to do all of this. And then likely basically fill up the whole thing. As long as it works. We'll see. Does it work? What's up with the pressure? What you doing, pressure? You should be increasing in temp and there it is. But the temp was too low. It should have been below the threshold for the minimum temperature, I think. It should have been adding heat earlier. Let's look at that right now. What was going on? This is in our advanced furnace. Advanced furnace gets loaded. You were supposed to, in the smelting phase, when you're trying to melt everything, you're supposed to be making sure the temperature is good. Branch relative if greater than 400. Oh no, I think it did work. It emptied and then filled. It's supposed to empty for a bit, and it did. It emptied until it got to 1 megapascal, then it filled. Okay, we're good. Everything's working right. Okay, so it's added all the things. All of them are at 0. They're all queued up in the line. You can see them back there. This is going to go to 1,000. It's going to empty, and then it's going to try and fill to a very specific pressure range. I'm going to remove these buttons. Can I remove these buttons? Oh man. This feels nice. This feels arrogant. This is too much. This is too far. I'm taking it too far. I'm gonna need these buttons one day. I'm gonna scream at the sky for my poor decision making. Okay, no more buttons. Buttons are gone. No more chutes. Chutes are gone too. I don't need these chutes. I do not manage a furnace. My furnace manages itself, thank you. Okay, so it's doing the thing. Now it's going for the specific range. Looking for a target temperature of 1,000, which it's finding. It's above the range now. It hit the right target. Ooh, I think it worked. I think we're done. But it could have come out as Regents. It looks like it's below 23.5. It might have had it for 1 tick and then released early. If it did, Regents will come out here. And they can just be thrown into the silo below. But hopefully it worked. Did you go up? Did anything get pooped? You're up to 15, so I think it worked. And then it's gonna go through the whole flow again. It's gonna find that this is low. It's gonna distribute everything. It's got enough of everything to distribute everything. This should be the last melt we need to do. We've already seen it work once. Will it work again? Let's find out. Awesome. It's working. This is one of the more... This is the one I was thinking might be tricky, but it seems to be okay. We'll see. If anything fails, ever, it just comes out here. So if we start having a rain of Regents, We know something's broken. And how are we on stuff? Still a little low on lead, 19. A little low on nickel, 5. What's next in line? Astraloy? What does Astraloy take? Copper, steel, cobalt. So we can do that one too. While this is while that's processing, I'm gonna write the program for Astraloy. We load the memory. Check lines, still okay, but running out. I don't know if we're gonna have enough to do everything. I think we might need a different program that's almost identical, that's listening for different, it's listening for opcodes, but it's listening for different opcodes. It's gonna do stuff on like 3 and 4. It could, or just 3. This one could listen for 3, and then it could do its job. It could also listen for 2 and do a reset as well. Yeah, I think that makes sense. Okay, so I don't need to do this yet, but I can in a minute. I'm just thinking, well, I guess we could split it. We could split it now while it's on the brain. So we're gonna run out of lines. We could probably add one more thing, and then we're all out of things that we can add. And we've got 2 more of these guys that we do want to have programmed, for sure. So we're gonna need another program to handle the memory for these, which can just be an extension of this one, basically. Or we can reuse this same system. So this is furnace recipe memory. We're gonna say this is F recipe mem 1. Maybe I'll say furnace recipe mem 1.
Vibration critical.
Confirm. We're gonna delete, I'm scared. First off, let's I'm gonna delete this real quick. Let's just get rid of this. Furnace recipe memory 1. Okay. So now we have furnace recipe memory 1. I'm gonna delete furnace recipe memory. And then we're gonna save furnace recipe memory 2. Okay. So furnace recipe memory 2 is actually like the exact same thing in every way, basically. Except it is not listening for 1 and 2 for reset and pop. It's listening for 3 and 2. So still when it sees 2, whenever there's a reset that's sent out there, it's going to see it and it's going to pick up on it. And it's going to clear itself. And it's not going to do this line of code. It's not going to clear the memory. This is going to be handled by the other chip. That's going to set it to 0. But it is going to pick up on that too, and it's going to clear itself. This just clears the stack. And then when it gets 3, it's going to do the pop thing. It's going to pop. It's going to set all of its values for whatever it's supposed to set, identical to the other one, but it's going to pop a different stack. So here we can swap out the entire stack with something new. Just get rid of all of this. It's kind of brutal, gotta do it one line at a time. Let's leave one example. We're gonna leave steel, maybe. Okay, leave steel for one example. And then what are we doing? Astroloy? Okay, so Astroloy goes... Ooh. Yeah, okay, we got it. I'm just thinking, but we're good. Okay. I'm getting ahead of myself. Let's do the Astroloy first, and then we can keep thinking about whatever we need to think about. Item Astroloy go here. To make Astroloy, we are going to need 3 ingredients. We're going to need copper, steel, and cobalt, with mostly steel. So the first one we're going to do is steel, which is that. We're going to need 10 stacks of that. We're going to need cobalt, which actually I think cobalt's like an ore. Let's make sure we get the right thing here. Cobalt ore is correct. I don't need this. I can delete this. I'm going to take this. This goes here. We need 5 of this. And then we needed copper as the last one. Just double checking. That's going to be an ingot. It is going to be copper. We are going to need to push 5 stacks of copper. Okay. So we got Astroloy, take steel, 10 stacks, cobalt, 5, copper, 5. I feel like I want to switch this order for no particular reason. Like the ore should be at the end for some reason. Okay, all good. And then it has temperature, pressure high, pressure low. Okay, I don't need this anymore. Let's delete it. So what temperature does this thing want to be at? And why do I hear explosions? I hear scary sounds right now. You want to be from 727 to whatever, so I think 1,000 is what we've been using. I'm going to say 1,000. It's your temperature, just the standard hot tank temperature. You are 30 to 40, so low, or high is going to be 32, and low will be 30. That should be good. Yep. Okay, so that'll do for you. I'm going to save you as recipe 2. Alright, so we now have another IC code that we can plug in here, which is listening to the same opcode. It's listening for opcodes, or the same opcode. They're listening to this memory, which is acting as the opcode. This guy's listening in. It's listening for a 2 and a 3. The 2 is the reset, and whenever there's a reset, it should reset 2, I believe. We might have to think about this. But at a reset, it's just going to clear its own memory, and then it's going to jump to main and keep looping. So it's listening for any time there's a reset for the system. It's going to reset all memory. They're all going to reset their stack. Okay, and then it's listening for 3. When it sees 3, that means it's its turn to start popping its stack and overriding settings. So the main memory is listening for 1, and at 1, it will go ahead and pop itself. And at 3, we're going to start popping in the second memory, is what I'm thinking here. And I'm not sure if this is the best way to do it. I think it's the way we can do it. We're just kind of solving problems on the fly here. But this is listening for 3, and then it'll overwrite the same outputs for the same memories, and it's just popping a different stack. In this case, it's going to have Astroloy as the first one, and then it'll have a couple others. Okay. So this guy rotates along, and then at a certain point, let's see, what kind of scaffolding does this thing need? This is saying when the stack pointer is empty, it's going to reset the stack. Okay. So in our case here, that's kind of not what we want. When the stack pointer is empty, we don't want to reset the stack. If the stack pointer is empty, then we have reached the end of all of the memory, because it's these 2 combined chips, and we want to reset everything. We want to reset the memory for this guy, and we also want to reset the memory for the other chip, I believe. We just want to call like the reset op, basically, which will reset both the chips and then should start again from the very beginning of the first chip. Okay. So I believe that's what we want to do here. So if this is equal to 0, then don't do reset. We want to do some, let's do some other things. Let's do a 3 here. We'll say you're going to set the memory, you're going to set the memory for fmem opcode. This is the memory device. Set the setting value to be 2. Set a reset, and then jump to main. So that's how we're going to reset. We're going to reset everything, and that'll reset this guy too. It's going to clear the logic here when that gets picked up. So go to 2, set that to 2, jump to main. The other thing should get picked up. Okay, and we could even do... Let's see, do I need to do this? I think I do. Yeah, let's do it this way. We set this to 2. And then even just to be 100% sure, I'm going to do a clear on our... No, actually I don't need to do this at all. I'm certain it's clear. Otherwise the stack pointer wouldn't be 0. What am I thinking? We don't need to be worried about that. The main thing is I want to reset the other chip, is what I'm thinking. Okay, so this is 3 now. We're going to skip these 2 and go here. And our conditional is wrong. First, I'm going to just die standing here and breathing heavily. 1 second. Let's change that conditional and add a second memory chip, which can live right next to the first one, right here. You are mem2. You're going to be right next to him. You get power. Okay. We're going to need a new chip for this. New chip is here. Okay, and then let's get that conditional right. I was looking at the condition on the... This guy. Let's see. I'm just thinking this one does behave a little bit differently. Because it's not, right now with what I'm currently writing, this is not going to give it the initial conditions that it needs. Or maybe we deliberately call the reset stack function. Just got to think about this a little. It's a little more complicated than I expected, but I think this is functionality that we want to write in. This is important. Our memory's not going to be long enough, and we want to be able to craft everything. So we should be able to listen in and walk through and just break it into a couple machines. It's just some added complication I got to work through here. So what do we want to do when the I was going to branch relative if equal to 0. For the stack pointer, I was going to branch 3, or branch relative not equal to 0. So if the stack pointer is not 0, then it jumps over and does stuff. Otherwise, it's supposed to reset the stack. So what am I thinking here? When we first read a 3 for pop ingot, we want to have the stack like ready to go so that we can immediately start popping and writing. So it should already be in a state where it's been like prepared and ready. We don't want to check to see it's empty and then do a reload like we're doing in the other chip, and we actually want to change the logic that we have in the other chip. It's going to need to be affected a little bit. So I think the initial conditions, we need to be setting this up so that the first time it hits 3 and goes to pop ingot, it's already ready to go. Okay. So what's that look like? I think for our reset op, we're looking to call reset stack, but then we're not looking to go to pop ingot after that. Just like go back to main and keep looping, perhaps. So let's see. So like we could start by initializing when we first boot up the program. We'll call reset stack. It's going to reset the stack. It's going to jump to main. It's going to start looping, doing the main loop. It's going to load the mem code. It's going to see probably like a 0 or a 1, nothing interesting for it. And then it's going to just be like looping forever with a stack that's ready to go until it sees a 3. And that's its time to jump in. At 3, it's going to go to pop ingot. It's going to check to see that the stack pointer is not equal to 0. And if that's the case, then it's going to jump over here where it's going to do its pop and pop everything off. So as long as there's a 3 in the system, it'll keep popping until eventually the stack pointer goes to 0. When the stack pointer goes to 0, we've reached the end of our list of things. It's going to call a reset. It's going to set the mem opcode to setting 2, which is going to reset the main memory. I don't even think we want to be listening for anything here for a reset. Reset op gets removed. We're not going to have a reset for this guy. This guy doesn't listen to reset because it calls, ooh, no, it needs to. Shit, I regret that. I need to bring that back. Shit. Shit, can I just cancel? I think I can just cancel and edit. I haven't really changed anything. I think I changed you to jmain and added one reset stack call up here. Okay. So it jumps to restack, a reset stack, goes back to main, does all the things that I was just explaining, blah, 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 does the things. You're still trained correctly with Astral? Yep, all good. Okay. Didn't lose anything. So we do want to listen for the reset because it's going to be called by the furnace sometimes, and when that does happen, then we want to reset all of the memory, and that includes this guy. So if that happens, you need to do a reset, and let's see, ooh. This could create a desync. Like, both of the things need to read the reset at the same time. No, actually, I take this back. Okay, so your reset op is different. Your reset is going to call reset stack. And that's all it's going to do. And in fact, we can get rid of the reset op and just say reset stack. This guy does reset stack. So when you see the call for reset stack, you're going to jump in here and clear your stack and reset it. So if you do this 2 or 3 times, it doesn't matter at all. As long as you have time to catch that too, you're going to get reset. Okay. So just thinking out loud, thinking through this a little bit, I think we're good. I think this is done. Not much changes to this. It's got a different set of memory. It's got a different opcode for when it's supposed to pop and overwrite stuff. 3. It's still listening into 2. For a reset. Too many jmains there. Pop ingot is going to branch equal to 0. Oops, branch relative. If equal to 0, stack pointer. 3. Branch relative not equal to 0. What is going on? Oh yeah, that got changed. Yeah. I forgot to change that conditional. Glad I'm walking through this. Branch relative if not equal to 0. If the stack pointer is not 0, meaning that there is memory in the stack and we haven't reached the end of the list, then go ahead and jump 3 lines, 1, 2, 3, and do your job of popping the next ingot. So it's going to pop the memory into where it's supposed to go. It's then going to set the mem opcode to 0. Okay, because it did its thing. It's going to jump to main. Okay, that all seems correct. And then when it's done, it's going to call that 2 to reset the everything. Yeah, where is that? I want to see that. Yes. You do the setting for 2. And then I think I wanted to also do something like this, maybe. So just in case you somehow don't pick up that 2 later, go ahead and jump to reset stack here. Instead of jumping to main, jump to reset stack. So reset your own stack. Don't only call the reset, but reset yourself explicitly. And then maybe if you pick up on that later, you can reset yourself again, sure. But make sure that gets done. That seems good. Where's the reset stack function? Did I lose that?
Hunger critical.
Or no, I'm sorry. I was thinking of the reset option, or the reset function. We did delete that. We minimized it. All we need to do is this. Okay, I think this is good. Now this just expects a 3 eventually, and then it will reset when it's done. Okay. We're going to edit this. This is the memory to... Have I saved you yet? I have. We're going to overwrite it. Confirm. Export. Throw it in. Breaks immediately. Needs the memop code for 1, I believe. What do we called fmemop code? So we rotate the fmemop code. Oh, I think I might have saw it. Oh, fmemop code. There it is. And that's all. Okay, so this guy's programmed. How we doing? Everything good? You're just freaking the fuck out? What is this? What is even happening right now? Was it because of you? Oh, it's because of you, isn't it? You messed some stuff up, didn't you? Uh-oh. I hope you weren't doing anything. I don't think you were. You look like you're just chilling. You're just chilling. You're filled up. Nothing was happening. I'm pretty sure this guy just caused trouble. What happens if I do this? Nothing. What happens if I do... I'm gonna save. I'm gonna turn you off, and then you should turn back on. Oh, you're on. Excuse me, what the fuck? What's going on here? Did it have to do with you? Maybe. Not sure. What if I throw a reset in the system? 2. Is that gonna trigger a reset? No. What if I turn this off? You get turned back on. Which has to be like you. What is going on? Import. Make this guy stop making noise. Edit. I'm hesitant to mess with this before I have a clear understanding of why we're in a funny state right now. What's going on that's turning on the thing. The mall manager's doing something funny. Might have to look at that, might have to turn it off and turn it on again. Anyway, we're already changing stuff, so I need to keep rolling with that. So this program, this is the main memory. This is memory number 1. This one needs a little tweak. I think at the very, very end, we need, once we get to our very last thing that we pop off the stack, which is going to be right here, we should pop like a -1 or something. Some sort of value for like end of stack. In fact, we probably want to call it end of stack. Let's say define end of stack is -999, which is some ridiculous number that we're never going to see on the stack as like a hash or anything. So we've got our end of stack just for human readability. This is -999, a number we should never see. So when we are popping the very first thing, let's see, where's the pops? Where's the pops? So right here, when we have our first pop, we need to check if this is the end of the stack. And if it is the end of the stack, let's see, let's just let's write this. Okay. So let's see, branch if equal R0 end of stack, pop next, something like this, pop next mem. This is like pop, go call a pop in the next memories I see, which maybe we don't even want to do as like a function. Maybe we just do that. Maybe we say branch relative if not equal R0 end of stack to otherwise let's see, otherwise we'll set the mem code here. We'll set this to 3 to pop the next one, and then we'll go ahead and jmain, or even tell this guy to chill for a second, yield, let the other thing pick it up, sleep for a full second so that the other guy can pick it up and do its thing, and then jmain to continue looping. So when we are at the end of the stack, so we're gonna need to do, actually we need to do a couple things here. We need to do this, and then we're also gonna want to say push onto the end of the stack. This is getting a little nasty, but sure. Let's maybe comment this. Okay. So just walking through this, in the very, very top of our stack, the first thing, the last element in the stack is end of stack, which is -9999, some number we're never going to see in the stack otherwise, and which is going to pop right here in particular, in this first pop. When we're popping off the first thing, when the stack is empty, it'll just be the one end of stack. We're going to pop that off. We're going to say branch relative if not equal R0 end of stack. So if it's not equal to the end of the stack, then jump over all this code, which is going to be what, 1, 2, 3, 4, jump 5 lines. So jump to here. Otherwise, if we're at the end of the stack, then we don't want to pop here. We want to pop here. We want to change it to 3, and we want to pop in the next one. So we're going to go ahead and set the mem code to a 3. We're going to push end of stack back to our stack, because when we popped it, then we removed it. In fact, we may even want to like peek. That's a good idea. Let's do a peek here. This is what peek is for, and then this one becomes pop. Alright, so peek is the same as pop. Almost. Pop is like pop the thing off and put it in a variable, and now it's gone. The peek is like take a look at it and copy it, but don't remove it from the stack, which is exactly what we want here. Okay, so we're going to peek at R0, we're going to take a quick look, and if it's the end of stack, then we're going to do this logic of setting the mem code, sleeping for a whole second, and then going back to the main loop and resuming. Okay, that's going to get picked up by the other memory, which is going to pick up the 3. It's going to do a pop. It's going to set the mem code to 0. So it's going to reset it. And then the next time this guy reads, it's not going to do anything. That sleep 1 is going to prevent it from accidentally like messing with the code too much or anything. Might even want to do like sleep 2, but I think 1's okay. I think 0.5 seconds is a tick, something like that. Okay, so I think this is basically all we need to be able to get this working. And then the mem2, when it runs off the end of its stack, it's going to deliberately call a big reset. It's going to call this 2, which is going to reset this memory and get everything all running again. Okay. I think this will work. We have to see. We have to watch it walk off the end of the list onto the next list and then rotate back into the beginning again. But something like this should work, except it probably won't because it wasn't even working before I wrote this code. So we got some stuff to figure out. What's going on here? What's going on? What you thinking about? Why you keep turning on? Why are you guys a 0? You should only be getting set by this memory or this memory. So I'm surprised to see you being weird, and I'm surprised to see you being set. That should be done by the mall. Okay, I gotta use the bathroom real quick, and then we can try and plug this in and see if we can rotate on to those last couple of variables to finish up the mall automation. Alright, I've used the bathroom. Where were we? Let's see, we were just exporting some code. I was thinking I'm going to just turn this off for a second. Let's turn off the mall manager. This is the furnace manager. This one's managing crafting. This one's managing furnace. I'm dying. Been dying for a while. Let's stop dying. Okay, so this is our mem1. I think we've already overwritten it. Let's make sure. Let's confirm. Let's export. Let's throw this down. That is off. So if you're off, then I should be able to turn you off. Correct. Okay. Might want to just like reset this. You are mem2. Let's go ahead and overwrite here and maybe think about this one last time, but I think this is good. I don't think we need to look at this too much. Yeah, you're doing the thing. We're good. The only other thing I can think is maybe when we set the mem code and do the reset stack, we should probably do a sleep here as well. Is that true? Does that matter? I don't think that matters. I don't think we need to sleep. It's not going to pick up on anything, I don't think. Yeah, we're good. I think I already talked through that too. Pretty sure I've already thought through that. We're good. Okay. So these guys are both plugged in and on. Nothing should be happening. Can I start rotating through stuff? What happens if I do a 2 on the memory? Why is nothing getting reset here? Are you plugged into the right thing? fmem opcode. fmem opcode. fmem opcode. What happened here? How did this all get set to 0? Everything went to 0 suddenly, and the light started turning on and staying on. Something to do with you, maybe? Seems odd. I was thinking we do need a little bit of a change here as well. Let's go ahead and import this code. Let's edit it. Let's take a look at where we are setting a reset. Or no, that actually happens in the furnace, right? Let's see, I'm just thinking... I don't think we need a delay in the reset either. I think we're good. Never mind. I thought myself in a circle there. Solved the problem. We're good. Alright, so you're working okay. Can I see, I want to just see, like, what is the stack pointer on you? Let's import. Just tell me the size of your stack. That'll give me an idea on what you're thinking internally. Show me your stack size in main. We're going to add one more line here. We're going to set DB setting for just SP. Show me the stack pointer. What is the size of the stack? Throw that in. Should show us something. Stack is at 0 until we get a pop, I think, and then it should go up. So we can start with that. First off, let's do a reset. Goes back to 0, which means you should have been run. We should have seen a reset. You did go, you're at 0, right? If I set you to A2, you go to 0, which means something reset you. State's still 0 here, though, so the stack pointer is still at 0, I believe. Oh yeah, that's supposed to be right. You're supposed to have been reset completely, and then the next pop, it should go up. That's how that does work. So that should change. We see 61. Something should have popped into here. It did. Okay. So I'm just kind of manually stepping through, in particular to see how does it handle transitioning between this chip and this chip. Is that going to work at all? It looks like things are working okay so far. We got steel popping up. Let's rotate through a couple more times. Should pop up to the next one. We can just keep adding ones. It'll keep rotating. Are you still rotating? I think you're probably still rotating. Yeah, just looks similar. Yeah. Okay, we're into the alloys. We're onto this one. We should have one, and then rotate to the second chip. So the yellow chip, or the yellow alloy, this guy is right at the edge between this one and this one. Let's see if it works. I'm going to save. I don't know if we need to. But if we look at this guy, we can see it's down to 1. This is the last one. This is that one end of stack variable that we threw in here. So when we rotate again, it should quickly switch to 3. It should trigger this guy. It should trigger it back to 0. So it should, the 1 should trigger this guy to trigger this to a 3, to trigger this guy to pop, to trigger this guy to a 0. It makes sense. Okay. Here we go. Ooh, look at that. What do I see? I see Astroloy. Astroloy wants steel, copper, and cobalt. Okay, that worked. Interesting. I don't believe it. I don't trust it. Okay, let's rotate again. You're still at 1. You can still peek at that and call a 3. So rotate again. Should hit the end of your stack. Should call a reset. We should go all the way back to steel pretty quickly, which I'm not seeing. Okay. What's going on here? You are at a 0. You are at a 0. I can't see anything. I should add the memory here too, I think. You're at a 1, so you didn't get reset. Let's see, did just like nothing happen and it changed to 0? Is that what that is? Getting closer. Okay, you broke. That's interesting. You're still 0. You're still Astroloy. Stack underflow, line 27. Okay, what's going on here? Import, edit. Stack underflow, line 27. 27. Wait, what? Excuse me, what? Okay, so you popped off the end of whatever, and then you immediately overflowed here, is what happened. So the stack didn't get reset when it was supposed to. Let's take a look at that. How would that happen? Because we're setting branch if equal to 0. Reset stack. Let's see. So reset option. Shouldn't we just like reset here? I feel like that would make sense. I forget, I think there's reasons why we're doing it this way, so I'm hesitant to just like move that code up. But what am I thinking? What do we want to do here? If we get a reset currently, we just clear the stack and call it good. Pop ingot, we don't want to... Ooh, okay. Just thinking, what's going on here? We called the reset. I was thinking if the reset option got read correctly by this chip, then it would clear the stack. It would set the opcode to 0. The next time it goes to pop, it would reset the stack and make the whole new stack, which looks good. So that should be working correctly if it picked up the 2. If it did, let's see. If it didn't pick this up and just got like another rotate command, another 1, then the bug should be that it would just be incorrectly setting the code to 3 because it never got its stack reset it was supposed to. So it basically just keep telling the astrology thing to keep showing astroloy. That would be the bug I expect. So I'm not sure. How's it reaching this point? Somehow it's getting all the way to here with one thing in the stack, which has to be end of stack. Nothing else could be in the stack. Because it's breaking here at line 27. So it's popping one thing out without a problem. It's trying to set that to R0. Can we see that? Or set that down here? Set it somewhere? How are you exploding? Can we make you do that again? In fact, can I just like load right before we broke things? Let's take a look at that again. Let's just run it back. Getting close here. Extend the memory. And then the whole mall's done. We got a dim screen. It worked it out. Alright, so here's where we were. This is right before the rotation. Everything is beautiful. You have one thing in your memory. It is the thing saying end of stack. I want to modify you as well really quickly. Let's import, edit. Let's do the exact same thing of just like show me your stack size. Show me what you're thinking in your stack. What you got for me? Let's go ahead and set DB setting to just the stack pointer to tell me your stack size. And double check this is the right one. It is. Looks good. I'll even save this. This is memory part 2. Confirm, export, throw this down. You show me your stack size, which is a 10. Which is a 10? Which is a 10? Which is a 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is a 10, isn't it? That's a good point. Okay, I'm going to save. Now we're going to rotate. It's going to rotate from this list into this list. We've seen this work. This goes to Astroloy like it's supposed to. This guy's stack should be empty now. Empty stack. The next one should trigger us. Let's take a look at the logic. We're looking at the right chip. We've got the next one is going to turn into a 3, which is going to do the pop ingot. Pop ingot's going to come into here. It's going to say branch relative if not equal to 0. It is equal to 0. So it's going to do the next line, which is to set the opcode to 2 for resetting. It's going to jump to reset stack. It's going to clear itself. It's going to reset its own stack. It's going to go to main. It's going to load the opcode, which might be a 2 now. If it is, it's going to go to reset stack. It's going to reset its own stack. It's going to go to main. It's going to reset stack. It's going to keep doing this until it's no longer a 2, which doesn't really matter. If it resets its stack 10 times, I don't really care. But eventually it's going to turn off of 2. Okay. And then let's load mem1. What's your clear do? Your clear clears yourself, sets the mem opcode to 0, jumps main. Okay, so actually something I do want here. I think we want to wait a second. We want to make sure, I want to be 100% sure that the other chip number 2 got the clear command as well. If you beat it in the race, then I don't want you to trigger this off before that guy had a chance to read it. So go ahead and sleep for even a single second. And make sure the other dude gets to reset too, whenever the reset op's 2. Then you set it to 0. And then you jump main. Okay. I think this is unrelated. This is a different bug. But I do want it. And then let's double check this is the correct program. It is. We save. We overwrite. Okay. Confirm. What up, Volley? Were you not using input curves? Ooh, you gotta use those input curves. Those make a huge difference. For sure. The kitty he's usually wandering. I don't know where he is right now. I think he's loafing in the hall. He looks real good. He's a beautiful loaf. He looks like a very small panther rug. Alright, so I like that change, but I don't think that changes anything. Overall, that's just doing the same thing. When we rotate it, it's going to reset everything. Hopefully. And then we should be re-entering this pop section here with an empty stack, because that got cleared. So it should just totally reset. All good, let's figure it out. I'm sure there's reasons. You have empty stack. You have one thing in your stack. I save, I rotate. Set this to 1. Just gonna rotate. Any breaking? No. Is it doing the bug I was suggesting? Where it might accidentally rotate into Astroloy forever. What's your state? Your state is still 1. You got reset to 30. Whoa. You have 30. There are 30 things in your stack. The only time this dude's stack ever is touched is during the push here. And every time, it's got a clear command ahead of time. So somehow, it caught 3... like 3 times the stack. It got 3 of these pushed in without ever clearing properly. What's up with that? Do we need a yield somewhere or something? I don't think so. That's really weird. Okay, so then if I rotate through again, are you just gonna go to 20 then? You're still chilling at 1, so we should be good to just turn this to 1. It's gonna turn to 3. This will rotate. Should go to 20 maybe. You're gonna brake. Stack underflow. Line 27. That is memory chip 1. Stack underflow. Line 27. So it's getting to this point. Somehow we're getting into pop ingot. Getting all the way down to here. Popping this and braking. What's going on here? What is happening? How are you braking? Do I need to take a break and a nap and look at you another day? Maybe. It's been a lot of stationaries. Kitty just came in yelling meow. That's a good argument. Oh, those are big meows. He's bored. Damn, I want to fix this. This is close. Okay, so something weird's going on with our memory rotation here. I'm gonna need to iron this out. I think in general, the way I'm playing with the opcodes should be able to do what we're trying to do here. This should be okay. I don't think I'm doing anything crazy. Or anything that has, anything fragile, I suppose. This should work okay. We're really close. I think this is a good pause point for now. I'm gonna go play with Kitty Cat and eat some food. But what did we do? We fixed the broken things. We tested the auto furnace and made small fixes there. We got them all stocked. We got the auto crafting done for everything all the way down to here. Working on extending the memory so we can get the last couple recipes plugged in. A little bit of some funniness there, a little bit of bugs. But this is like 1,000 lines of code. We'll be able to work out whatever 5 or 10 are wrong here. And then that should be the end of the mall automation. That will have the whole process done, from ore being dropped off in the entrance, through processing and smelting and sorting, distributing to the furnaces, crafting the rare alloys, stocking all the machines, giving good feedback on what's missing where. This is solid progress. I'm feeling good about it, and I'm feeling ready for some food and a break and to play with Kitty Cat and to look at this code soon. I want to keep working on this, but I think a pause is a good idea. I'll take a look at this next time, I think. We got to get this thing finished. That's the last little bit of logic before this thing is totally done. And then maybe work on some nitrogen stuff. Maybe swap out the coolant for oxygen so that we can bring the temperature down further and use that as a coolant for the cooling on the nitrogen. And then all the nitrogen in the lines and that we've collected, we could start moving into the evaporation chambers and getting those filled up and seeing what kind of cooling we can do. So that'll be fun. Get some good liquid cooling going, and then we can finally move on to liquid rockets, the eventual end goal that I've been pushing towards for many sessions. But yeah, this is good. A little bit of a dead end here at the end, but I'm sure we'll work through it, and good progress overall today. Things are working well. Mall's looking good. I'm excited to wrap that up. Next time, I'm going to take a break and go eat some food and hang out with Kitty Cat. You have a nice day, Internet. Thank you for watching.